Next topic is sequential collections versus parallel collections in Scala. In Scala, we'll see that parallel collections is available, which enables us to do parallel computation, and we'll then compare the performance of parallel computation with sequential one. Let's start with an example. Say we want to access two web pages, bbc.com and cnn.com, and these are URLs and as a list. Then we have a helper function that is get page size, and just this one line using Scala library, we can feed this URL and get the whole web page as a string. And here this is returning the length of the string. Okay, so that is what this helper function does. Now remember what is our goal. We want to download the page, and then we want to measure the length of the page, and we have two pages to work with. And first time, let's see what happens. So we want to work with those two URLs sequentially in the first time, and that means a regular program. So here we use a for loop, get each URL, and then call the helper function and get the size, and we print that. That's straightforward, and we have to invoke this function to make this happen. So if we run this, maybe it's a good idea to run it quickly. Let me copy this and let me go to my Scala, and let me maybe start a file and prepare it. This is what we have, and then let's run it using Scala 2.12, and the full path is this, and then see what happens. That should access bbc.com and cnn.com, get the web pages, and these are the length of those two HTML pages. That means how many characters are there, something like that. Okay, so that was successful. Let's return, and this time this happened sequentially like a regular program. Now we remind ourselves that Scala supports parallel computation. If we use Scala library's parallel collection, so that's supported by a Scala library, then it's very easy to work with parallel collections, and parallel computation is easily achievable. And this style spares developers from low-level parallelization details. That's a big plus. Remember that to work with parallel collection in Scala easily, we should work with Scala 2.12 or earlier, not the recent version Scala 2.13, which has some non-obvious issues which we have to fix before we try this. So I will be using 2.12. Here is an example. We have a list of strings, and after that, if we just say dot bar, that means we are working with a parallel collection. We are working with a parallel list which supports parallel computation. And as an example of parallel computation, say we want to convert each of these strings to uppercase. These are not fully uppercase, right? We want to convert them to full uppercase letters. That's an example computation, and we can work, we can make this happen parallelly on each of these strings. And how to do that? Get this parallel collection, which is last names, and then say dot map, and this is the anonymous function. That means given a string, convert the string to uppercase. That is the anonymous function. So map will apply that anonymous function in each of them, which we have seen before. Here only difference is that computation will happen parallelly, right? And that will be the result. The result also returned as a parallel collection. Okay, not only map, we can use any other standard higher order method to do this parallel computation, as an example filter. And here the anonymous function is, we want to check whether the first letter of the word is greater than J or not. That means only those names or last names which start with a letter which is greater than J, only those words should remain. And that means Smith and Rod, which starts with S and R greater than J, that remains. But mind that here also this computation and this filtering has happened parallelly over those, how many strings were there? 1, 2, 3, 4, 5, 6 strings were there. So on each of them, this checking happened parallelly, and after the checking, these two are returned. Now let's compare sequential computation with parallel computation with a simple example. So here we have a list of 100 numbers, and that's a sequential list. And say we want to add 10 with each of the numbers in the list, then normally what we do, we get the list and we apply map with this anonymous function. All right, remember, if you are still not familiar with this underscore symbol, what is the full form of the anonymous function? The full form of the anonymous function is this, right? That given x, x will be added with 10, and the shortcut form of the same thing is this. They are exactly same thing. Okay, now on the parallel side, what we have to do, we can just get a parallel collection using this dot per magic. So this list 2 is a parallel collection, and then the same code, using a map, and apply this anonymous function on each of these is also available on parallel collection, and that will enable parallel computation. Understand that this computation, adding 10 with each of the number, doesn't depend on each other, right? These 100 numbers are there, and we want to add 10 with each of those numbers. One addition does not depend on the other addition, right? They can happen parallelly in a comfortable way. There is no problem, correct? So in this sort of situation, parallel computation really helps, and it can really save our time. Now we want to compare how much time we are saving. Maybe it's a good idea to take a bigger list so that we can see a lot of saving. So 1 million numbers, I believe, are there, and then same computation, and this is happening serially. And on the other side, if we do parallel computation, that is happening here, and we want to check the time difference at this point minus this point to get the serial computation total time, and we want to check T4 minus T3 to get the parallel computation time. And I ran it on my system using Scala 2.12, and these are the time I get. The serial execution takes this much, that means 1317 milliseconds, where parallel computation takes only 266 milliseconds. So we are saving at least by a factor of 5, correct? Okay. Now, if you're interested to set the degree of parallelism, that means how many threads will be working parallelly, here are some boilerplate code you can use. And in this particular example, the degree of parallelism is 2. Now, some practice to understand this parallel computation. So here, list is a parallel list. And if we print using for each these items, then what happens? Think about it, and mind that this printing is happening parallelly, so it prints the above numbers in random sequence, not in exact sequence, to understand that things are happening parallelly. Maybe let's run it to test this out. And I go to my test.scala, and there we can quickly change things, and these are the things, and I can just again run it, and you see things are not happening in order, right? Because things are happening in parallelly and we have no control which one happens first. Okay, it's very important to think about it. Now let's come back to web page handling. So here we have those same two web pages, BBC and CNN, and we want to get those pages and we want to get the sizes of these two web pages. But if you think those two web pages are independent, so getting those two web pages can happen parallelly with comfort, right? And then the size computation can also happen parallel, because those two are two independent things, right? Now let's try to do it parallelly. So here get page size concurrently is the function we are calling, and in that function this parallel collection uses a map. And now inside the map, what happens, get an URL, that means bbc.com as an example, and then get the page size using this helper function, right? And things can happen parallelly. I think it's okay to skip, not to show the code. Maybe this one I will run. Here we want to compare this sort of web page handling computation, one in serial fashion, one in parallel fashion. In particular, there are 4 pages, and first maybe where serial, let me understand serial computation T2 minus T1. So T2 is here, T2. So here things are happening serially, right? Get page size here, and things are happening serially. There is no dot bar. And in the next case, T3 to T4, in between, get page size concurrently, where this the parallel collection we are working with. So that's why things will be happening parallelly. So now let's see, can we run this code, and let's see how much time we'll be saving in downloading these 4 web pages and computing their sizes. It should be interesting. And let me get that code here. Here we go. Things should look fine. And then let's run it. It's running. Things are happening parallelly, hopefully. And first here things happened sequentially, and then here things happen parallelly, right? But of course the sizes are same, the page sizes are same, and the serial execution time was 3000 millisecond and parallel execution time is 1000, and so, right? So we can see that a lot of time we have saved. That should be very cool. Let's go back and mind that in this web page handling process, you can face some exception if your web page has some bad characters or some unusual characters, and there are some ways of handling this exception using try catch block. Just take some look and should be good.